Hi, everybody. We are working on section 7.4 today, and I am a little dressed up. It's the day before Halloween, and here at school, I'm wearing my costume. I'm supposed to be a Jedi. I look more like an old guy in a bathrobe. But anyway, let's get going. Section 7.4 compound interest. So I'm going to the formula sheet, this mathematics of finance formula sheet I posted. There's a couple of formula sheets for you to post there that I posted there for you. You can use whichever ones you want, but I would stick with one. So I'm looking up the formula for compound interest. Do, 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 do. Using the future value at compound interest formula. Let me write down the formula. Now, the one I have says future value equals present value. I'm not going to use FV and PV, future value. I'm just going to use F. Future value equals the present value times 1 plus R, and it says M, but I'm using N because that's what most formulas use is N for that. Times N times T. That's the power of N times T. And I always put that in parentheses. So that's N times T. So N is the number of times our money is compounded. Compounded means how often they calculate the interest in the money. So if they say, annually, we're going to compound the interest annually, that's once a year, N is 1. Semi-annual, that's twice a year. Here it says quarterly, and is 4 times a year. Quarterly. Monthly, and is 12. Weekly, and is 52. There are 52 weeks in a year. What else do we have? Sometimes they say daily. We don't use, depending on how many days you have in a year, what we use is something called banker's days, and we just use 360 since it's a nice round number. 360 for daily. So I think we got most of them here. So Maria invests $3,000, so that's the present amount. By the way, sometimes this formula, if you look at other formula sheets, instead of future value, they call it annuity, A. So that F sometimes is an A. If you're looking at it in your homework, I think they're going to use A equals P instead of F. So we're going to do after 1 year. Time's always in years, so time equals 1 year. Compounded quarterly, N equals 4. Here's our interest rate. So I'm just going to plug everything in. We want to know how much we're going to have in the future. Right now, the present value is $3,000. And we're going to compound this interest. The interest rate is 5%. And N is 4. It's compounded 4 times a year, quarterly. Raised to a power, N is 4, and the time is 1 year. So this is 4 times 1, not 4.1. That's 4 times 1. So I'm going to put that in my calculator now. And you want to put it in the calculator exactly as you see it. And really practice this because many people in the actual class have gotten this wrong. So I'm going to try to bring this here and kind of show you as I'm typing in. Maybe I should try to make this bigger. There we go. Let's see how we can do this. We're going to do 3,000 parentheses 1 plus a fraction. So I hit the ND button. 5%. Now, some people get this percent. That's the percent button. That's going to percent. So we want that percent button in green. So you hit second percent, 5%. Then I arrow down 4, close the parentheses. But now we have to raise it to a power, and this raises it up. This button here raises it to a power. Do you see? And I always put powers in parentheses, so let's do it. It's 4 times 1. 4 times 1, not 4.1. Many people are getting that wrong. And when I hit enter, so we started with $3,000 in the bank. After 1 year, compounded quarterly, we have $3,152.84. Always round money to the nearest cent. So my answer was, if I put $3,000 in the bank and I get 5% interest, it says 83.6, but we always round money to 2 decimal places, $3,152.84. Okay, so we're going to try to do the same thing. Same thing with 12 years. So the formula is exactly the same. Well, we change a couple of things. We're starting with 3,000. 1 plus 5%. Compounded quarterly, it says. Except now, remember, I'm going to try to show you up here. There we go. The formula was n times t. The formula was n times t. N, how many times is compounded, is 4. T is how many years, and we're going to keep the money in the bank for 12 years. So this is the formula, and I'm going to plug this into my calculator the same way I did last time. 3,000 parentheses, 1 plus a fraction. %, divided by 4, close parentheses, raise it to a power of 4 times 12. And if we keep this $3,000 in the bank for 12 years at 5%, we end up with $5,446.06. If we rounded to 2 decimal places, it was 6.4. So since there's a 4 after the 6, the second decimal, we keep it as 6. So that's how much you have in the bank after 12 years. If you never touch it and you just put it in there and don't worry about it. So this is compound interest. Let's keep going. We want to look at these really quick on our calculator just so we know how to type these in. E raised to the 4.3 power. E is Euler's number, and it is used for continuous compounding. So we need to know where that's at on our calculator. So for E raised to the 4.3 power, if you look on your calculator, right above this ln button, it says e to the x. So I'm going second ln, and it gives me e raised to a power. So I just type in 4.3, and I hit enter, and that's what the answer is. E is really 2.71. If on your calculator you go E and raise it to the 1 power, that's just E. Do you see it's 2.71? It's like pi. It's a number that goes on forever. It's called Euler's number, and it's a number similar to pi. It goes on forever, and it's used a lot in financial formulas for continuous compounding. So I just wanted to make sure we could do that. Let's do the next one, 2e to the third, 2 times e to the third power, and you get this. Okay, just want to make sure everybody's able to type those in. Now we'll continue on. Maria invests $3,000. So that's her starting point, her present value, her starting amount of money. Interest rate is 5%, compounded continuously. T equals 12 years. T equals 12 years. So here is compounded continuously. You need to go to your formula sheet now and look for compounded continuously. Using the future value with compound interest formula, and then next to it in parentheses, it says compounded continuous. And it looks like this: FV equals PV e to the RT. So future value equals a present value times e to the RT. And I always put this RT is in power. I always put it in parentheses. So if we want to know how much she has in her account after 12 years. So it's the same $3,000 as up above at 5% interest. We should have a little bit more because the interest is compounding. They're adding money into the account, even though it might be small little pennies, if that, continuously adding money, compounding the interest. Future value equals present value times ERT. Once again, present value is $3,000. $3,000. Then we're going to multiply it times E. Interest rate is 5%, and time is 12 years. So we're going to put this into our calculator. $3,000 times E. So you got to get the E there. Raised to the power, and my power is always going to be in parentheses. 5%. Make sure you get that percent symbol in there. Times 12. And when I hit enter, I get $5,466.36 rounded. So my answer to this problem is 5466.36. Okay. Let's see what else we got. Okay, so number 6 is a different formula. Not necessarily a different formula. It says find the amount Juanita should invest. So we're trying to find the amount. We're trying to find the starting amount, the present value. She will have 50,000. This is the future value. This is how much she will have in the future. We're trying to find out what the present value is, how much she needs to put in the bank right now. So she has $50,000 20 years later. How much does she has to put in the bank now? So 20 years later, she has $50,000 and she gets 8% interest. So I'm looking at my formula sheet. And we're going to use the same compound quarterly interest. By the way, compound quarterly means n equals 4. We're going to use the same formula. F equals P. F equals P times 1 plus R over N. I use N instead of M. Raised to the N times T. But we're looking for P. Do you see? We're looking for P. So I'm going to take this to the other side by dividing it. So I end up with F divided by 1 plus R over N raised to the N times T. That's a present value. Do you see? I just divided both sides by this 1 plus R over N times T. So that cancels out. And if I divide it 1 plus R over N times T, this is what I get down here. Those cancel. Okay, so now I just need to put everything I know in here. My future value will be $50,000 on top. That's how much I want in the bank in the future. The interest rate is 8%. N is 4. This is N. N compounds 4 times a year quarterly. N is 4 times T is 20 years. And this is my present value will equal this. So I'm going to plug this into my calculator, and you got to be very careful with this. When I type this into my calculator, and so many people in my class had messed this up, you have to practice typing this in and getting it correct. So first, I'm going to type in the fraction button, and on top, I just have $50,000. On the bottom, I have parentheses, 1 plus a fraction of R, which is 8%, divided by 4. I arrow over and close that parentheses. I'm going to raise it to the power. When you raise a power, you put this arrow up button, and my power is going to be raised to the 4 times 20, close parentheses. And you see, I have everything typed in exactly as I see it on my paper, and I hit enter, and do you see, I get $10,255.49. So, in order for me to have $50,000 20 years from now, I have to put, trying to get my pen. I can't find it. There it is. I have to put $10,255.49 in the bank now. And then 20 years later, I'll have 50,000. That's cool. All right, let's see what else we got. Okay, so this problem is a little bit different as far as a formula goes. What section are we on? Are we on the same section there? I think we're still on 7.5, right? Yeah. I haven't seen anything change. Okay, so Juanita decides instead of buying a car every 5 years, she doesn't want to be stuck making $400 a month payments. So she decides to put $400 every month in the bank, mutual fund, earning 9% interest, compounded monthly. Compounded monthly is N equals 12. If she does this for 40 years, so time is going to be 40 years. How much will she have in her mutual fund 40 years from now? So she's going to put $400 in the bank every month for 40 years. And it grows 9%. So that's pretty good. Let's see what happens there. We need a formula for that. So she's making payments. Calculating your future value of annuity with present payments. So I'm looking at my formula sheet, and it says future value equals the payments 1 plus R over N. Remember, I use N instead of M. Raised to the N times T minus 1, all divided by R divided by N. Okay, so putting this in a calculator is no easy task. The payment's going to be $400 every month. It's 1 plus R. The interest rate is 9%. And we already said was 12. Compounded monthly, that's 12 times a year. We're going to raise it to N, which is 12 times 40 years. Minus 1 down here. And so instead of brackets, since my calculator doesn't do brackets, I just do another set of parentheses. All this divided by R, which is 9%, divided by N, which is 12. Okay, so this is not easy to type in. You have to type it in exactly as I see it. Wow, as you see it that I wrote here with the parentheses and everything. So I'm going to start us off. Let me make this a little bit bigger. I'm going to start us off with a fraction because we have a big fraction. We have $400. Now, if you don't put the correct number of parentheses or parentheses in there, it's going to tell you error. So we have 2 parentheses here I have to deal with. One is for the whole thing, and then the next is for the inside. So I put 2 parentheses, 1 plus another parentheses with a fraction, 9% divided by 12. I arrow over, and then I do my parentheses. I raise it to a power, and that power is 12 times 40, parentheses, 12 times 40, close parentheses. Then I arrow over because I want it to come back down when I subtract 1, and there's another parentheses there. Do you see I have this big parentheses is for the whole thing, and then there's another parentheses that was for that. So I'm going to the bottom now. I arrow down to the bottom, and I do parentheses 9% divided by, I should have just did a fraction. I think I can go back just so everybody sees that. Fraction 9% divided by 12. I before I put the parentheses, I arrow over and then put the parentheses, or you mess it up. Okay, I think I have everything in here. Now I hit enter. I hit enter. It said 0. So I definitely typed something in wrong. So I'm going to try it again. This time, hopefully, $400 payments. 1 plus parentheses fraction 9% divided by 12 raised to a power 12 times 40. Oh, I think I must have typed a 0 in somewhere. Minus 1, close parentheses, all divided by 9. Oh, it's all divided by a fraction, 9%. Except 9% should be on top. Give me a second. Okay, so I had an extra parentheses in there. Um, so I think I figured it out. When you do all this, you should get that answer 1,872,528. Let me write it down. 1,872,528.11 rounded. 5, that's a 2. So you put $400 in bank for 40 years at 9% interest, you have $1.8 million in the bank. That's pretty good. So let's see if I can pull that up on my calculator, how it looked when I typed it in. It's kind of hard to see, but I typed in an extra parentheses. This is wrong. I have this parentheses should be for all of this. So this parentheses right here should be deleted. I had that. Do you see when I wrote it in here? In reality, I should. Well, this one covers. I actually have one extra. That's why I said I don't need this parentheses. This one covers this one. So I had one extra in here. If I hit enter, what I did was then I went back through this thing. Somehow, I don't know how I did it. I went back through and deleted. There we go. I went back through and deleted it. There we go. There we go. That's what I did. Hit delete. And now I have the correct number of parentheses. This one is for the whole closing. And now when I hit I still messed it up. Because I entered that other one in. Anyway, when you do it, you should have 1,872,000. So that's a tough one. So practice that one. See if we can find something similar to that. I think we're just about done here. In the next 5 years, Campbell wants to save $30,000 for a down payment on a house. How much must he save? Okay, so this is similar. We're trying to find out how this person wants $30,000. In 5 years. This is going to be the future value. How much must they save per month? So we're looking for what the payment should be. What should the payment be to get $30,000 in 5 years at 7.5 compounded monthly n equals 12? So we're looking for the payment. And it says calculating a sinking fund payment. Parents wish to have $80,000 for their child. It gives us compounded monthly. So that is the formula. So I'm going to write down the formula from the formula sheet. It says payment equals the future value times R over N divided by, and once again, this is a parentheses thing, R over N raised to the n times t minus 1. So this is finding the payment if we want $30,000 in the bank in 5 years. So I write 30,000 up here times our interest rate is 7.5%, all divided by n. N is 12, compounded monthly. The number of times compounded, n is 12. And what I normally do is I always put, if there's more than one thing happening on top, I put the entire top in parentheses. I don't think you need to do that on this calculator as long as you put everything on top of a fraction. Then on the bottom, we have a parentheses and a parentheses, 1 plus r, 7.5%, divided by 12. Raised to the power of n is 12 times the number of years is 5, minus 1, and then we close that big. This one closes this one, and this one closes this one. All right, so I'm going to put that in my calculator exactly as I see it, with the parentheses and all. So first I type in a fraction. And I type in a parentheses with 30,000 times a parentheses with a fraction, 7.5% over 12, arrow over to do my parentheses. And I'm looking at that formula. There was nothing there, right? Payment, right. There was no power for that. So I go down to the bottom. I have 2 parentheses to start me off. 1 plus a fraction, 7.5. Oh, a fraction, not a mixed number. One plus 7.5%. Over 12. And this whole thing is raised to 12 times 5. Except I didn't type in 12. Minus 1. Parentheses. So I think I got it in there. And the payments I need to make are $413. What did I do with my pen? $413.64. There it is. So my calculator shows $413.64. So I need to make those monthly payments every month for 5 years, and I'll have $30,000 in the bank. All right, so hopefully this video helped. I think I covered everything I wanted to. All right, you guys, that's all I wanted to cover in 7.5. I hope you guys have a good day.